Hello guys, welcome to Solving Solutions, your number one channel where I get solutions to all your solving problems. It's nice having you in class again today. How have you been? On today's tutorial, we are going to show you one practical use of buffer in GIS. So recently, I worked on a project that I was given a point of maybe incident, just like we have here. And then I was told to get an extent of, let's say, 1000 meters squared. That's an area of 1000 meters squared, or maybe whatever value the area is. Normally if you want to buffer, you have a point and then you introduce or you impute what the buffer radius or the buffer distance. Let's use that for now. And then you now have your extent around your point, right? Good. So now in this case, we were told the extent we need, the area we need, the extent will have to cover, right? Good. So let's say we are going by the principle of the area of a circle, which says pi r squared. Now the area of the circle is given to us because we want to believe that the buffer we want to use is a circular buffer, right? Good. So since the area of a circle is pi r squared, pi is a constant, so we need to find what the radius, right? Good. So the radius will now simply mean the square root of the area divided by pi, right? Good. Now this is actually very interesting because most times if you say, okay, the area needed, the extent you want to cover is 1000 meters, and then you impute the 1000 meter, you eventually find out that you are very off, completely off the tax you have been given, or let's say the aim of the tax you've been given. So now let's come back to QGIS. We go to vector, we go to geoprocessing, and then we come to buffer. Now one of the important thing to note is that whenever you are working with this type of tool, especially buffer, your data should be in a projected coordinate reference system because it uses what? Linear units, right? Good. So now we are going by this example that we want to get the radius so that the area covered will be what? 1000 square meters. So how do we go about it? We come with a calculator. Now we know that the area of a circle is pi r squared, right? Good. So we know the area, which is a 1000 meters squared. We know pi, which is a constant. However, we don't know the radius, and the radius is actually what? This buffer distance that we are going to impute. So in order for us to fix that, we are going to use this formula. So we have a over pi, which is 1000 divided by pi. Pi is actually a constant, so you can use 22/7, or you can just invoke the constant directly. And then the next thing is that we get the square root of that answer. Remember, you can impute all of them at once, but I just decided to break it down, which means the buffer distance we are going to impute there is 17.841. So we have 17.841, right? Good. So the segment, let's increase it a bit so that we can have quite a fair circle. So let's make it about 30. And then the next thing is for us to run. So we have an extent, and then this is the point of incident, right? Good. So the idea is that this extent covered should be 1000 square meters. So if we open this buffer layer to the attribute table, we have a column for area, right? Good. We start toggle editing, we come to the field calculator, and then we are trying to update an existing field, which is the area, and then we search for the formula for area, which is this $ area, right? Good. So when we click on OK, you now see that we have 998.926, which is approximately equal to the 1000 meters squared that we need, right? Good. You see that's about just 1.074, right? So basically we've shown you this is actually an application of buffer, because if you have been given a task, we want to know the radius, it will not be told, but we want you to give us an area of about this extent from this incident point. So this is the principle if you want to use the principle of area of a circle, or if your buffer will actually be what? A circular buffer. So we believe we've provided solution to this particular problem. We'll see you with another interesting one. Until then, keep staying safe and have a fantastic time. Bye.